text. Okay, so let's just start the questions and sessions. Is my screen visible?
Yes, sir.
Okay, thanks, Sakshi. Hmm. A very good evening to all of you again. So today we are going to have our week 3 live sessions for biochemistry. Here we'll be taking few problems and solving those related to biochemistry problems. So the first question we have is, for the following peptide, write down the structure, find the C terminus and N terminus residue, and highlight the peptide bond linkage. So it's a very basic question. Anyone of you want to answer? So here the question is, for the following peptide, write down the structure, find the C terminus and N terminus residue, and highlight the peptide bond. The structure I have already written. G correspond to the glycine, K for lysine, L for leucine, W for tryptophan, Y for tyrosine. So the N terminus is glycine, C terminus is tyrosine. There are three peptide bonds. One is this, another is this, and third is this. So all other peptide bond linkages are highlighted. Is there any doubt? Okay. So I hope if there is any problem in understanding how to draw the peptide structures from the C terminus to N terminus, which amino acid will come at C terminus, which will come at N terminus, please ask so I can explain you and we can have a healthy discussion. Fine, let's take to the next question. Okay, this question is just from the basic organic chemistry. Question says arrange the reactivity order for a nucleophile. There are different carbonyl compounds are given. All of them carboxylic acid, acid halide, amide, ester, acid anhydride. So if you notice, there is one carbonyl bond in each of them. This is the carbonyl bond, this is the carbonyl bond, this is the carbonyl, this is the carbonyl, this is the carbonyl. And it has electrophilic center that this carbon in all of them is electrophilic in nature. So it's asking if once the nucleophile is attached to the carbonyl, let's say any nucleophile, this nucleophile has to attack. So the question is asking if it has to attack, which of these carbonyl compounds will react first with nucleophile? The carbonyl compound which will react first with the nucleophile will suggest that it has the better reactivity. That means the electrophilicity of the carbonyl center is more than others. So what will be the order? Any answer? What will the most electrophilic center? Any one of you? Answer please. So we can discuss if something is not clear. Okay. Any one of you? Here is the reactivity order of carbonyl compounds. So most reactive will be acid chloride, then acetonide, then it will come ester. Before to ester, after ester there will be acid, and then least reactive will be amide. So why amide will be the least reactive? Any answer? What do you think? You guys think that okay, why amide is the more least reactive than even carboxylic acid? So we are talking about electrophilicity of this carbon center. This is because the lone pair of this nitrogens are readily available, and then it is readily available and readily in the conjugation. So the electrophilicity of the carbonyl is satisfied, electron density is satisfied. So amide has less requirement. Amide carbonyl has less requirement of the donor electrons. That means it will have poor reactivity. Fine. This question was from the basic organic chemistry perspective, and you'll understand why the question was placed over here. Okay, so let's move on to the next question. Another question for the following peptide, write down the structures. Find out basic and hydrophobic amino acids. So please write down the structure on your notebook. What year you are having at the current time. So you need to write the structure of KLYRGFHWI. K corresponds to lysine, L corresponds to leucine, Y corresponds to tyrosine, R for arginine, G for glycine, F for phenylalanine, H for histidine, W for tryptophan, I for isoleucine. So draw the structure. You can see on your screen and draw the structure. Then we can move ahead to the next part of the question. So whenever you'll have a pen paper, you'll draw, you'll understand. And in organic chemistry, it's very essential drawing. Drawing is very essential. Then you will understand it very clear. Otherwise, it won't be clear in your mind. So I would always suggest that one should always write on pen and paper. I hope you guys will understand and write it on pen and paper. Take time and write it. Then you'll not miss one or two methylene, you'll not miss the stereochemistry, and you'll remember what's the structure for one which amino acid. Let's say how many lysine, how many methylenes are there in lysine or in arginine, so on and so forth. So I hope everyone has written the structure. If not, we can wait for 1 2 more minutes. Please complete the writing the structure. Yes, so can anyone tell which are the amino acids? They are basic in nature, or else they have a side chain, basic side chain. So basic side chain, lysine do have basic side chain, one amino acid. Then you have arginine, and then histidine is also slightly basic nature. So three amino acids we have which are basic in nature, and then hydrophobic ones: tyrosine, phenylalanine, and tryptophan. These three amino acids are hydrophobic in nature. Is this clear to everyone? Okay, so let's move on to the next question. Which are the following reagents that can be used for N-terminus amino acid detection? So let's say you have a peptide and you wanted to understand which of the amino acid at the end terminus. So earlier detection methods were used. First uh, reagents will use to detect end terminus and then followed by hydrolysis. And then suppression will lead to tell, okay, this is the end terminus amino acid. So this was the question from the detection of the amino acids from the conventional methods. So here the question is the answer could be the A and B. Dinitrochlorobenzene and acyl chloride. These both can react with N terminus. First, let's say this is the peptide. You have this peptide. It reacts with DNFB. It will react. Amine will react, and then related this dinitro will be installed on the N terminus. Then we perform the acid hydrolysis of peptide bond. All the amino acids will be separated from all the amino acids. Amide will get broke, and we'll have three different amino acids. The amino acid with this dinitrobenzene will be at the N terminus because N terminus amino is free. So whatever amino acid was present, that will be the N terminus amino acid. So these two compounds are used for amino acid detection. N terminus. Fine. Okay, let's move to the next question. Here we have a question, a slightly lengthier one, but if you will understand, it will be pretty much easier. It is asking which one of the following statements best describe about hydrolysis of carboxypeptidase. So it is carboxypeptidase is an enzyme which cleave the amide bonds. So it is asking what is the true statement for the carboxypeptidase. There are two types of carboxypeptidase: carboxypeptidase A, carboxypeptidase B. So the first statement says carboxypeptidase E removes the C-terminal amino acid only arginine or lysine, and carboxypeptidase B removes the C-terminal amino acid not arginine or lysine. Second statement says carboxypeptidase A removes the C-terminus amino acid not arginine or lysine, and carboxypeptidase B removes the C-terminus amino acid only arginine and lysine. So these both two statements are contradictory. So we need to understand which one is correct. So carboxypeptidase A and carboxypeptidase B both remove the C-terminal amino acid only arginine or lysine. None of this arginine lysine system. So basically the answer lies if we know what is the cleavage side of carboxypeptidase A and carboxypeptidase B, we'll be able to find the correct statement in this question. So let's see. Does anyone have any idea this carboxypeptidase uh, cleave? What is the cleavage side? Okay, let me see who's there to join us. Teta Tripathi. So carboxypeptidase. Teta Tripathi. Do you have any idea what's the cleavage site of carboxypeptidase? If not, it's okay. I'll tell to you guys.
No, sir.
Okay, it's perfectly fine. The cleavage site of carboxypeptidase A remove the C-terminal amino acid, not arginine or lysine. Carboxypeptidase B remove the C-terminal amino acid only original acid. So these two are the statement for the carboxypeptide enzymes. So which statement is correct in this case? Just match with these two things and let us know. Anyone? Anyone of you? Yes, there are two statements written right. Just match the statement and find out the which option is correct here. Hello. Okay, so regarding to these two statements, the option B is correct. No one want to respond at all. That's what surprised me. Correct answer was also written. Anyways, which of the following statement best explain why the reaction below shown would not be satisfactory? So if you see this is the amino acid that is phenylalanine and this is alanine. A coupling reagent is used, coupling reagent called DCC is used to couple this amide bond, acid and amine coupling to yield this peptide bond. So it is saying this will yield the poor yield. What could be the reason? The reason behind it could be there are two amines and two carboxylases. If we mix all together, there will be random coupling. So desired amino acids, desired peptide sequence will be having a very poor yield. So for that, if you wanted to couple the amine of this and a carboxylic of this, then you need to have protected this one and protected this one. phenylalanine and carboxylic acid of alanine should be protected, and then only it will give the efficient coupling because there will be only one acid group and amine group to couple each other. So that's what the option says. The DCC causes rationalization of amino acid. Not really. So there is nothing to stop each reactant from undergoing self-condensation. Very true. An amino group is not nucleophilic enough without a protecting group on it. No, that's also not true. Anybody is if you guys having a difference of opinion or you think differently or you think the answer we are discussing is not right or you don't understand it, please ask. Carboxylic acid group is not electrophilic enough without a protecting group. That is also not true. So option B is correct. Fine. So let me take you guys to the next question. Oh, a little lengthier one, but it will be interesting to solve this question. It says a peptide has the following amino acid composition. It has the 2 alanine, 2 phenylalanine, 2 alanine, 2 phenylalanine, 2 glutamic acid, 1 arginine, 1 lysine, 1 valine, 1 leucine, 1 glycine, 1 serine. Okay, these are the composition of the peptides. Reaction of the intact peptide with densyl chloride followed by hydrolysis creates a derivative of alanine. If you remember in the first previous questions, I said that densyl chloride will react the N terminus of the amino acid. And let me take you to the slide. Yes. So instead of this B, if you have an densyl chloride also, it will react with the N terminus, and then if you followed by the acidic hydrolysis, it will reject this conjugate of amino acid at the N terminus. So the question, according to the question, the N terminus amino acid sequence will be alanine. Amino acid sequence at the N terminus it will be alanine. Okay. A specific cleavage of the intact peptide with a particular enzyme produces fragments with following sequence. Fragment A is glu, glu, phenylalanine. Fragment B alanine, serine, leucine, arginine. Alanine, valine, glutamic acid, phenylalanine. These three, if you use one enzyme, that will chop and generate three different fragments. So, according to the first information, it says it will have a alanine at the N terminus. Hello, is I'm audible to everyone? So, whatever is getting explained, if it is not clear, we can discuss. Okay, so it says what it says that the N terminus sequence will be alanine. So first fragment it will not be because the first N terminus sequence is not alanine. So B or C, it will be one of them. It will be at the N terminus. It will be at the N terminus. Fine. So let's put this one of them at the N terminus and then see whether chopping, it will be same as because here we are going to use only one enzyme. So whether it will be basic amino acid chopping or it will be uh, hydrophobic amino acid chopping with the enzyme. So let's put this fragment B first. If you put fragment B first and then we put fragment C, alanine, serine, leucine, arginine, alanine, serine, leucine, arginine, and then we put fragment A or C. If we put A and then further fragment will be this one. So the top then there will be amino acid phenylalanine that will be hydrophobic in nature. So the same enzyme will not work. Same case if you put this first, then also it will not work. So the sequence it will be alanine, valine, glutamic acid, phenylalanine. Then glutamic acid, glycine, lysine, phenylalanine, and then serine, leucine, arginine. Because here same peptide has been used, same amino acid, and same enzyme has been used for cleavage site. So what trypsin cleavage site is a basic amino acid, lysine and arginine. Chymotrypsin it's a hydrophobic amino acid, tyrosine, phenylalanine, and tryptophan. Okay, first before going to that, let's understand. Okay, how this enzymes works. Basically, these enzymes are serine proteases, in which the serine amino acids, histidine and aspartic acid, these three combination amino acids will lead to degradation of the peptide and protein amide bond. So first, what will happen? This here I'm going to explain the mechanism how this trypsin or alpha chymotrypsin enzymes works. First, what will happen? This histidine will obstruct the proton of serine, and that will be then this will attack to the amide of the substrate peptide. And then what will happen? Then the negative charge will be stabilized by the positive negative charge will be stabilized by the aspartic acid 102, and then it will again come back and obstruct the proton of histidine. It will be neutral. So you have now this ester bond formation between serine and the peptide. This part of the peptide is gone. It's chopped up already. Now once you have water, it will affect the proton and then it will lead to the hydrolysis. So both the part will go off and it will lead to the hydrolysis of amide bond in the active site of the enzyme. So this is how enzyme works. So active domain, this is the active domain of trypsin. This is the active domain of chymotrypsin. Chymotrypsin active domain will have a sequence which will interact with the hydrophobic amino acid residue and it will hold it there. Same as trypsin, it will have a negatively charged hydrophobic pocket. So it will coordinate with the basic amino acids such as arginine or lysine and hold it there. So that's what the option is. Well, in this option, regarding to this, will be correct. So reacts of the intact peptide with densyl chloride followed by acid hydrolysis creates a derivative of alanine. This integrates N-terminus amino acid alanine. And then if we put this sequence, then same enzyme can cleave and provide these three fragments. This is correct. Which reagent used for this specific cleavage? Here it is asking which what was this enzyme used for specific cleavage. So, chymotrypsin, hydrophobic enzymes like this one, phenylalanine and phenylalanine, both these two cut, right? Next question we have, the peptide is one of the polypeptide chain of multimeric protein that contains two non-identical subunits. Okay, let me see. Someone wants to join right now. Hello, Bilal. Welcome to our live session. Is this right time to join? Anyway, enjoy. Please try to join on time so you can get benefited maximum. So it is asking if you have a peptide that is coming from the multimer protein that has a different subunits. So if you react with primary structure the protein, what problem might be seen when analyzing the primary structure of the protein if subunits were not separated? If you wanted to analyze the subunits of the primary structure by using methods like reacting with fluorodynabenzene or carboxypeptidase. So, what could be the problem if these subunits were not separated? So, first, saying fluorodynabenzene might react with two different amino acids. Very true, because it will react with the N-terminus. So, if you have a two different subunits, it will have a two different N-terminus. So, it will react with two different entities. Carboxypeptide might not react with C-terminal. It will react with C-terminal. Mercaptoethanol might not reduce disulfide bond. If the side disulfide bond is there in the two subunits, it will react. Lithium borohydride might cleave peptide bonds randomly. No, it's not correct. So option A is correct here. Next question I have, the trypsin fails to cleave the peptides. Which peptide will not be cleaved by trypsin? The answer is right here written. Anyone can tell why? Anyone? Okay. Trypsin, the cleavage side is basic amino acid cleavage side. So let's find whether, which of them have this basic amino acid. Valine, alanine, lysine, and lysine. This is the cleavage site for trypsin in this peptide. Glycine, lysine, valine, alanine. This is the cleavage site for trypsin in this peptide, and this is the cleavage site for and glycine, lysine, valine. All of them will have cleavage site with trypsin. Now we need to see what's different there. So there are different C terminus of these. So wherever the C terminus at the C terminus C side of lysine or the adenine, there's a proline. So if you see the proline, it completely gives a turn. So then it will not be possible for enzyme to hold it in the active pocket and cleave this. So this will be the missed cleavage. In all the cases where there is a proline with lysine, it will not be able to cleave that side. So correct answer is C. Is this clear to everyone? Because if you see the proline and lysine, then you'll understand that if you draw the structure, then you'll understand that it give a complete turn, and this turn lead to the destabilization in the active domain. Unless and unless it will not be getting holded in the active domain, it will not be able to get cleaved.
Sir, please explain how we can check which is the cleavage side.
Okay, so cleavage site for the enzymes, that is very specific. You need to remember. For instance, in case of trypsin, the basic amino acids, C side of the basic amino acids, that is lysine and arginine. Okay, and
Okay, sir.
for chymotrypsin, it is hydrophobic. So tyrosine, phenylalanine, and tryptophan. So these, if you see, I have explained it here. These amino acids, these enzymes, have a special active domain. So let's say it's a chemotrypsin. So it has an active site which will hold this hydrophobic. Here is a phenylalanine, whether it's phenylalanine, tyrosine, or tryptophan, it will hold into this, and then this bond get activated, and this cascade pathway will occur, and you will see the cleavage, that peptide bond. See side of this one. Fine. So this is for
Yes, sir.
hydrophobic, and same as if you see here, as on this active domain of trypsin, where you have a amino acid which will hold negatively charged amino acid which will hold this basic amino acid. Basic amino acid mean it will be side chain will be positively charged, and then it will hold it here. Then this cascade first get activated, and this carbonyl will get activated. And this carbonyl will get activated then only. Okay.
Okay, sir. Thank you, sir.
Yeah. Okay. So next question. It's very interesting question. If you'll pay attention, you'll be enjoy solving this question. Okay. Chemical analysis of a octapeptide lead to the following observation. We have a octapeptides, and we are having going to have a chemical analysis of the octapeptide. If you do acid hydrolysis lead to the complete degradation of peptide bond, and it will give individual amino acids. So what it will give? It will give two arginine, one leucine, one lysine, methionine, phenylalanine, serine, and tyrosine. So these many amino acids it gives when it is treated with acid hydrolysis. Again, it is saying the carboxypeptide is a releases serine. So okay, so carboxypeptidase A releases serine. So carboxypeptidase A react with the C terminus amino acids and remove it, cleave it. So in a way, it is saying that the C terminus amino acid is serine. So function of the peptides, function of the enzymes like carboxypeptidase, trypsin, chymotrypsin, we need to remember. Okay, advanced reagents release leucine. So Edman reagent release leucine. So Edman reagent it react with N terminus. Cyanogen bromide forms two peptide with following amino acid composition. It is saying this if you use cyanogen bromide, it will give two peptide with this arginine, phenylalanine, serine, and arginine, leucine, lysine, methionine, tyrosine. It is again not showing what will be the sequence. Then it is saying trypsin form the following two peptides and two amino acids. So then it is saying if we treat that peptide after peptide with trypsin, it will give one arginine, one serine, and then these two peptides. So this much information is given. So from the above information, the structure peptide is deduced to be. Did anyone not understand the question first? So this is all analysis of the peptide sequence. If you have a peptide, you don't know sequence, you want to sequence it, and by using chemical methods. So analysis was being done and the result was shown. So we need to deduce it with the results. It is saying serine is the C terminus, leucine is the N terminus. Fine. In all the cases, leucine is the N terminus, serine is the C terminus. Okay. Next, it is saying the cyanogen bromide forms two peptides with the following amino acid composition: arginine, phenylalanine, serine, arginine, leucine, lysine, methionine, and tyrosine. So, what it's cyanogen bromide? What it does? It cleaves the C terminus of the methionine. In all the cases, it will cleave the C terminus of the methionine. So, C terminus of the methionine. So, out of them, the this will be the peptide sequence of 5 and 3. So it will cleave from here, from here, from here. Now it is next question is coming that trypsin from the following two peptides and two amino acids. So if you treat this with trypsin, what it will give? It will release serine. It will give serine, and then it will give the peptide of methionine, phenylalanine, arginine, and then it will give leucine, and it will give lysine, tyrosine, and leucine. So if we solve with systematics, so first we can fix the C terminus and N terminus. C terminus and terminus is fixed, then cleavage with the cyanogen bromide, it's methionine. It is showing that 3 amino sequence will be this side and 5 will be this side. So this is methionine. And then we'll put the trypsin. Then what we'll find that the data from the trypsin digestion, it will give one serine, arginine, phenylalanine. So this sequence will be the right option. Leucine, tyrosine, lysine, arginine, methionine, phenylalanine, arginine, and serine. This one, option A will be correct answer. Why not option B? Because if you treat with trypsin, here you'll receive serine. Fine. And option C will be eliminated. If you treat with trypsin, you'll not receive serine as such. So this option will be eliminated from here. Now out of the two, we need to understand why out of these two, which one will be the right answer. So let's clip. We'll have a serine, then we'll have a clip side this one and this one. So it will give leucine, tyrosine, arginine. But one will have leucine, tyrosine, arginine, but no. It will have a, it is saying it gives leucine, lysine, and tyrosine. So it gives leucine, lysine, tyrosine. According to this, the option A is correct. Okay, so if the peptide is given and the information is given for the chemical analysis, then we can deduce the what will be the structure, what will the C terminus, N terminus, and what will be the sequence of the amino acids. Okay, fine. So next again the similar question: a peptide with the molecular weight 11,000, 1100 failed to react with Edman's reagent. Okay, failed to react with Edman's reagents. That means Edman's reagents react with N-terminus. That means it do not have N-terminus. What it indicates? It indicates that it can be a cyclic peptide. Amino acid analysis gave a composition phenylproline glycine lysine 2 times. The peptide of the treatment with trypsin gives another peptide Y with identical amino acid composition as that of X. Okay. Edman degradation of Y gave the following partial sequence: phenyl and glycine. The structure of X is, so here the option is given. So it's cyclic peptide for sure. So from the given information, we can say that peptide X is cyclic and dimer of two identical fragment of Y. So dimer of two identical fragment of Y. Because proline trypsin did not chop. Recently we discussed that proline, if you have proline with lysine, it will not chop off. And trypsin will cleave from here, then you will get the identical peptides. So this will be the sequence of the peptide. Fine. How many types of the structure present of the proteins? So let's understand a little bit more basics. Well, how many types of the structures are present in proteins? Anyone? Let's see if you guys are listening or connected or not. So how many types of the structure of the proteins are there? Anyone of you? Okay, there are four types of structure. Primary protein structure. It will be a sequence of chain of amino acids. Secondary protein structure. It will be alpha helix and beta sheet. Secondary bonding of peptide backbone causes the amino acid to fold into repeating pattern. Tertiary protein structure. Three-dimensional folding of the pattern of the protein due to side chain interactions. And quaternary will be protein consisting of more than one amino acid chain. Quaternary protein structure. So there are four types of structure. So what are the forces are involved in the various form? So in primary it's a amino acid peptide bond. In secondary it is a hydrogen bonding involved in intermolecular, and in tertiary it's hydrogen bonding, hydrophobic interaction, hydrophilic interactions, and anionic bonds. And in quaternary it's a one-to-one interactions. So interactions get increased, the complexity of the proteins is to get increased. Which of the following is responsible for denaturation of the protein? Very simple question. pH change, organic solvent, heat, all of the above. Is changing the pH can lead to the denaturation of the protein. Let's have a discussion and understand how, why.
All of the above.
Okay, why do you think pH changing will denature the protein? Means what kind of if you change the pH, let's say you make it acidic or you make it basic. For instance, in acidic cases, pH is one around one. What will be the chemical entity, chemical changes or chemical forces, bonding changes that will lead to the denaturation of the protein? Because we are understanding the biochemistry, let's talk in terms of bonds. There will be changes in hydrogen bonding network, right? Organic solvents, heating, all of the above will lead to the denaturation of protein. Correct. So in all the cases, hydrogen bonding network will be disturbed. Let's say you heated the hydrogen bonds or weakly bonded. If you heat the the energy is provided, then bonds will get break and then it will lead to the denaturation. Same as organic solvents. A structure that has hydrogen bonds between different segments of polypeptide chain arranged side by side. Its primary structure alpha helix beta plated seed tertiary structure. What could be the answer? It is asking about hydrogen bonds between different segments of polypeptides chain arranged side by side. If you see the structure drawn here, if you see the structure of alpha helix and beta plated chain and hydrogen bonding network over here. So this is alpha helix and this is beta plated chain. In alpha helix, there is a hydrogen bonding not side by side, but in beta plated chain there is hydrogen bonding from the side by side. So beta plated chains will be the correct answer. Fine. Which of the following amino acids are known as helix breaker? Proline and glycine, isoleucine and leucine, valine and threonine. Which of the following amino acids are known for helix breaker? So correct right answer, proline and glycine are known as helix breaker as they disrupt the regularity of the alpha helix and backbone conformation. Like glycine do not have any side chain to interact, and same as proline, it gives a turn. So it disrupts the regularity of the alpha helix. So they are known as helix breaker. Next question we have: in what order would the following amino acid be elevated up with a buffer of pH 4 from a column containing an anion exchange region? It's a histidine, cysteine, aspartate, and valine. So answer it will be a column containing an anion exchange region releases amino acid in reverse order of their isoelectric point. So the amino acid with the largest isoelectric point is released first. Because of the given pH, it will be the amino acid the highest concentration of positive charge. So histidine will have a highest, and then valine, then serine, then aspartic acid. So it will elute in this order. Okay. Next question we have: gel filtration chromatography separates protein based on their answer this question. Anyone of you? Gel filtration is chromatography separate the protein based on their effective size. So option D is correct. Against ion exchange chromatography, proteins bound to resin can be displaced by increasing the strength of ionic buffer, size of the sample, column volume, column width. So it is strength of the ionic buffer. The ion exchange chromatography, the protein bind reversibly to the inert region through ionic bonds. The displace and eventually elute the bound protein. The ionic strength of buffer can be increased. If we increase the ionic strength of buffer, it will elute fast. Another question we have: the catalytic efficiency of two distinct enzymes can be compared based on which of the following factor? Km, product formation size of the enzymes, or kite by Km. The answer is D. The efficiency of the enzyme catalyzed reaction depends inversely on the Km. Lower the Km means greater binding. The directly on kcat. So overall efficiency would be determined by the kcat by Km. So which one of the following statement about the alpha helix structure of the protein is correct? It is maintained by hydrogen bonding between amino acid side chain. It makes up about the same percentage of all proteins. It is stabilized by intramolecular hydrogen bonds between amide hydrogens and amide oxygens of the polypeptide chains. It includes all 20 amino acids at equal frequencies. So option C is correct. Alpha helix structure is maintained by intramolecular hydrogen bonding between NH of the one peptide linkage with carbonyl oxygen of another peptide linkage involving fourth amino acids in the same chain. Okay. What are the important parameter of protein purification? So important parameter of protein purification is molecular weight, charge, solubility, and affinity. These four are the important parameters. So process based on molecular weight is gel filtration spread native protein molecular weight and ST space separate by subunit molecular weight. Based on charge, it's ion exchange chromatography, native gel electrophoresis, isoelectric focusing. So last point, I want to tell the physical property of protein that influence stability, therefore determine its for its rigidity of the backbone, amino acid interaction with water. Okay, let me see who are join us in the last moment. Good. Yes. So you are join us at last moment. Very much welcome. Physical properties of the protein that influence stability and therefore determines for its rigidity of backbone, amino acid interaction with water, that means hydropathy index of for side chain, interaction among the amino acids, it's electrostatic interaction, hydrogen bond, ss bond, volume constants. So with this, thank you all for joining. If you have any further question, feel free to drop an email regarding